When honeybee scouts find a food source or a nice site for a new home, they communicate the location to the rest of the swarm by doing a waggle dance. They point in the direction of the site and dance longer for sites that are farther away. The rest of the bees use the duration of the dance to predict the distance to the site. The table here you see on the screen shows the mean standard deviation of the distance in meters and the duration in seconds for 7 honeybee scouts. Now, looking at a graph of the scatter plot, does it appear to be a linear trend? And if so, is it positive or negative? Well, since a line's already been drawn, you might get a sense that, yes, this does appear to be linear. So there does appear to be a strong linear positive trend to it. So the longer the dance, the farther the distance. All right, in terms of what's the explanatory variable and what's the response. So recall that the response variable is the one you're trying to predict. So what we're trying to predict here is the distance, and we're using the duration to make that prediction. So again, we're trying to predict the distance to the site, so the explanatory variable is the duration, and the response variable is the distance in meters. So find and interpret the slope and intercept of the regression line in context. So define these. Notice in this table we're given the mean and standard deviation. So the way we start off finding the slope. We find the slope by using these standard deviations here. And we find the intercept by using the means. Specifically, the slope is given by the standard deviation of the y values over the standard deviation of the x values times the correlation. So the standard deviation of the y values is right here, 1,653.7. That's the standard deviation of the distance we're trying to predict, so that's my y value. The standard deviation of the x value is the 1.4001, and then we multiply by the correlation, 0.99419. And you can put that in your calculator, you should get up 1,174.3. So what that means is that for every additional second in the waggle dance, the distance to the site is around 1,174.3 meters farther on average. So recall that slope is basically in terms of the y value per x value, so meters per second. So every additional second, we're so many meters farther. As for the intercept, that's going to be the average y value, so the 1,664.3, minus the slope that we just found, times the average of the x values. So 1,664.3 minus 1,174.3 times 1.7571. Put them together in your calculator, you should end up with negative 399.1. So what does this tell me? Well, if the waggle dance lasted 0 seconds, that indicates the site would be negative 399 meters away on average. Well, waggle dances don't last 0 seconds, so this is pretty much just nonsense. Obviously, distances aren't negative. All right, if I want to predict the distance to the site, if a honeybee does a waggle dance lasting 1 minute, 1 second, or 3 seconds. Well, first off, let's get our equation. So put those pieces of information before. We found the intercept was negative 399.1 plus the 1,174.3 seconds. So I'll go negative 399.1 plus 1,174.3 times 1. And I find out that for 1 second, it comes out to be 775.2 meters. For 3 seconds, let's just go back to put a 3 here. For 3 seconds, it's going to be 3,123.8 meters. And again, think of these as averages, not exact values. Now, suppose a honeybee does a waggle dance for 3 seconds, and the actual distance is 3,400 meters. So, if I want to find the residual, I take that 3,400, that's the actual value, I subtract off that predicted value for 3,123.8. And my residual comes out to be 276.2. So the actual is 3,400. Predicted is 3,123.8. Residual, actual minus predicted, 3,400 minus 3,123.8, which is 276.2.